All right, here's what I intend to do today. What I'd like us to do today is do a little bit more on chapter 15. Not all of it, but at least a little bit more of the naming aspects of it, and amides, what are amides, and maybe a couple amides to learn the names of those. We'll leave the reactions for Monday. The homework will be due next Wednesday. Where did I put it here? Right here. Chapter 15 homework will be due next Wednesday, or not next Wednesday, 2 weeks from today. And then let's see, this is 12:30, so about 12:20 or so, we'll stop and you can get into your teams, and I'll be available to talk to each team. Where are you? Do you have any questions? Have you found articles to read, to pursue your topic, that sort of thing, okay? So we'll have at least 20 minutes to work on your project, your class project, and then that'll give you all spring break. If some of you are going away, that's fine. If some of you aren't and want to poke around and find out more information, you can work on it. All right. We skipped over this molecule because I said, well, you really don't know how to handle that yet. It's really, all of these others were simple amines. Methylpropylamine, dimethylamine, methylamine, diethylmethylamine, okay? There's 3 things on that one, but they're all ethyls and methyls. There are 3 things on this one, but we're going to get up into a butyl here, and we'll see that we could call that butyl ethyl methylamine. We could call it that, but that's not satisfactory on one getting that big. So let's figure out how to handle something like that. We talked about common names of amines. So this is the one. This is the persnickety one that we have to deal with. And to start dealing with that, I want us to focus on this molecule for a second. This is one you're going to need a 3x5 card on. It's a benzene ring with an amine, an NH2. It's aniline. So if you go from cyclohexane to cyclohexene to benzene to toluene to benzaldehyde to benzoic acid, and now we're at aniline. That's a whole family of 6-membered ringed molecules that you should be familiar with. Let's look at that for a second. I'm going to draw three molecules down here. The first one is going to be aniline to make a point. So there's your benzene ring with your NH2 group at the top, and that's the one we're talking about right now, aniline. So let's take a look at this. I want you to see how we would handle naming these 2 molecules to learn something. Oh no, I don't want a carbon up there. I want a nitrogen. Hydrogen. I'm going to put a methyl group right there. And then the third one over here is going to be somewhat similar. I'm going to put a nitrogen here, a hydrogen, and a hydrogen, and I'm going to put the methyl group down there. So all 3 of these, the parent name is going to be aniline. Aniline. But we've got a methyl there on the nitrogen. We have a methyl here on a carbon on the ring. So let's just figure out how we would handle this. This is aniline. Where would you say is carbon number 1? At the top? Okay, right here. Yeah, here's the name of this molecule, aniline. So we're going to number off of there. That's carbon number 1. That's carbon number 2. That's carbon number 3. So how would we finish off this name?
3-methyl aniline.
There you go. See, at the beginning of the semester, you wouldn't have known that.
Nope.
Maybe not.
I didn't know anything.
Okay? But see that? It's just rolling off your tongue now. Man, you guys, we could start our own company. If I had any money. All right, 3-methylaniline. Well, what are we going to do with that one? Where is that methyl group? It isn't. It isn't. Leah, it's not sitting on the first carbon. It's bound to the nitrogen. You see that? It's not bound to a carbon. So we can't call that 1-methylaniline. We're going to call it N-methyl. You like that? It's on the nitrogen. I'm going to go back to my office and say, I don't know, I think it was funny, but I don't know. They like nitrogens. Okay? N-methylaniline. So we're going to use that N like it's a carbon number. It's not a carbon. It's a nitrogen. So it tells us that methyl group is on the nitrogen. It's bound directly to the nitrogen. We don't have a number. It's an N. N-methylaniline. All right, so you're going to see this you're going to start seeing this show up in the names of amines. You're going to see a capital N. It's a capital N. I'll put a little n, because that means like normal propyl, normal butyl, or something like that. So it's not a little n, it's a capital N, methylaniline. Okay, let's just look at this slide again. So there it is right there. There's N-methylaniline. Here we've got an alkyl group on the nitrogen. We have an alkyl group on the ring. So it's 2-ethyl N-methylaniline. So it's still N-methyl, but the ethyl group is on the second carbon. 2-ethyl N-methyl. Okay, here's one where we got a methyl and an ethyl right on the nitrogen. So it's N-ethyl N-methylaniline. What if I had something like this? Since it likes to put them over there. Let's try to name that one. I like that. N-dimethylaniline. Remember when you were naming molecules that had 2 methyl groups in them and it said dimethyl, and I said, okay, if it says dimethyl, give me 2 numbers. I don't care if it's on the second carbon. I don't care if the methyl groups are on the second carbon. Both of them. Then it should be 2, 2, dimethyl whatever, pentane. So here, we got 2 methyl groups on the nitrogen, so we use the N twice. N-dimethyl. All right, let's take a look at this molecule here now, because it's feeling neglected back here. Everything else got a name. I didn't get a name. So here is this molecule. Let's start right there. So for the time being, let's worry about these in just a second. But what I've got there is the longest chain, 4 carbons, right? So I'm going to work off of the longest chain. So what is the name of that part of it so far? We got 2 other things on here, but we'll get to those. What do you think, Marcos? Butane. It could be butamine. That's the other IUPAC name. But let's treat this like it's a substituent. And we call it what? Butane, but it's what's the name of that substituent? What? No, it's not N. Remember, what is an NH2 group called? NH2. Amino. An amino group. Amino. So the amino, where is the amino? 1. So that's a 1 amino butane. 1 amino butane.
So does the amino start where the N is?
The amino is the N.
Okay.
Yeah, the amino is the N. But the N is attached to the first carbon. This number 1 is referring to that first carbon right there. So it's 1 amino butane. And so now we need to pick up these 2 substituents. We got this here, and we have this here. So what do we have? Okay, N-ethyl, N-methyl 1 amino butane. And just to drive home the point that we do need to be specific about this, we could have had this molecule. All right, you can see there's several of these. There is the 1 amino butane, but this is 2 amino butane. So that's why I'm saying that we're not simple enough to just use a simple name and be unambiguous about it. So this is 2 amino butane. And then we have to bring in our N-ethyl, N-methyl, 2 amino butane. So those are 2 different molecules right there, 2 different structures. And we have a way now of handling those kind of structures. Yeah. And if we had this molecule, so it's still 2 amino butane, but now it's just simply N comma N dimethyl. Two amino butane. Okay, let me give you one and you name it. Name this molecule. Yeah, go ahead and name that molecule. Okay, someone have a name? Casey, got a name?
Is it 4-methyl and N-methyl 3-amino-pentane?
4-methyl, what'd you say?
N-methyl 3-amino-pentane.
Okay, it is 3-aminopentane. We agree with that? Does everybody agree with that? It's 3-aminopentane. It's an N-methyl 3-aminopentane.
It's 2 there.
Okay, 2-methyl. Casey, you see, yeah, you got 4. You started here. 1, 2, 3, 4. But if I start over there, 1, 2, 3, it doesn't change where the amino group is. It still is a 3, but it gives that a lower number. Okay? So you're going to want to count off in such a way to give your substituents the lowest numbers. Yeah.
Does it matter if you put 2-methyl and then N-methyl, like in that order, or could it be N-methyl, 2-methyl?
It could be in either order. Could be in either order. And even you will see, you're going to see this back here. And I said usually the miscellaneous things are out front. Why? A lot of times you are going to see it this way, 3-aminopentane, because the other IUPAC, and this is an IUPAC name, let's just look at the other IUPAC name. I'm not going to try to name everything by both IUPAC names all the time, but if we were going to look at the other one, this would be 3-pentanamine. Okay, so it would just take this and shove it on into the parent name right here, pentanamine. So you could see that this wouldn't be out in the front of the name. In this other IUPAC system, the amine is actually incorporated. We're taking pentane, dropping E, and adding amine on the end of it. So the other name here would just be this right here. We could put the N-methyl out here. 2-methyl. As a matter of fact, you know what you could do here? You could put N-2 dimethyl. You could actually do that. Those would all be acceptable. This could also be called N-2 dimethyl 3, whatever you want to call it now, aminopentane or pentanamine. Okay, you can see this is unambiguous. It says I got a molecule here. It's got 5 carbons. It's got 2 methyl groups. One's on the carbon number 2, and one's on the nitrogen. And you could draw that molecule by any one of those names. And what I told you in chapter 15, I may say, draw that molecule. So you need to kind of know what we're talking about here and draw it. Or I may say, name that molecule. And you could give me that name, or that name. Those would all be correct. If you give me a name that an organic chemist would, it would be unambiguous. Like if you called it dimethyl pentanamine, you say, well, that's close, but it's not telling me where all the methyls are. Or even the amines. Not telling me how the structures fit together. So just that and that is not specific enough. You need these qualifiers here. Say, where are these things? All right, so in chapter 15, if you give me a correct name, and if it is a simple amine, like if it is a simple amine, on the homework I have, something like this, and you could name this with you could give an IUPAC name to this molecule. Something like that. How would I want to draw that? Let's do it up here. Take that one off there. You look at that, and yeah, could you give an IUPAC name for that? Yes. But it's complicated. The common name is, it's a common name. Triethyl. Triethyl what? Amine. All right? That's simple. It's a common name. There are 3 ethyl groups here on a nitrogen. So I think you have a molecule like that on the homework, and sometimes students do, they give me the IUPAC name for it, and it's about that long. It's got N's all over it. And it's correct. It's correct. I don't mark it wrong. I'm just saying don't, squeeze yourself through the eye of a needle when there's a simpler way of doing it. Okay. So here's your 3x5 card again. Aniline. Don't worry about memorizing these, but you can see we got an aniline and a methyl. Without the NH2 on there, that's toluene. Without the methyl on there, it's aniline, and they're just pulling that toluidine. They're just toluidine. They're combining those names. This is a molecule that shows you the ortho, the meta, and the para position, and how that would be used in a name. So you got orthotoluidine, metatoluidine, and paratoluidine. A little bit about the properties of amines. The oxygen-hydrogen bond is polar. Oh, I got that backwards. The oxygen is nitrogen, is negative. The hydrogen is positive because of the big difference in electronegativities between oxygen and hydrogen. Well, same sort of situation with nitrogen-hydrogen bonds. They are polar, not as polar as the oxygen-hydrogen bond, because notice where nitrogen is. It's moving over, and remember the highest electronegativity is fluorine. The next highest is oxygen and chlorine, and then it starts diminishing. So the bigger the difference between the electronegativity of the two elements involved in the bond, the more polar the bond will be. The more separation of charge you will get. So you can get stronger hydrogen bonding between water molecules than you will get between amines. But you will get it. So there's the positive hydrogen bonding to a negative nitrogen on another molecule. That's what hydrogen bonding is. It's an attraction between molecules. Yeah, that hydrogen is bonded to that nitrogen right there. That's not called hydrogen bonding. That's a covalent bond. But we're getting hydrogen bonding to that nitrogen. So their boiling points will be a little bit higher than what you would expect just based on their molecular weights because of this attraction the molecules has for one another. And likewise, there's solubilities in water. There will be some solubility in water, not as good as alcohols, because we're not talking about a oxygen-hydrogen bond, we're talking about a nitrogen-hydrogen bond, but they can hydrogen bond to water molecules. And so they're attracted to water molecules, they'll dissolve in them to some extent. You could expect as the chain length gets longer here, the solubility decreases, just like alcohols. Okay, I'm going to come back to these other species and reactions. But what I want, before we leave amines, I want to introduce you to the fact you will come across heterocyclic amines. Cyclical molecules that contain more than one element in the ring. So not like benzene. Benzene is not heterocyclic. It has all carbons in the ring, but pyrimidine has 2 nitrogens and 4 carbons. Purine rings, it's 2 fused rings together. Look at, there's 4 nitrogens in that little ring system. Where do these come up? Where do you see these 2 rings? Have any idea where you see these rings?
Is that germ? Oh, never mind. I'm like, is that Germex? But that's Purell.
DNA and RNA. Those are nucleic acids. That's the nucleic acid. Those are the rings. So you add adenine, thymine, guanine, cytosine. They are based off of these 2 rings right here. 2 of them come off of the pyrimidine ring. 2 of them are made off of the purine ring. So they're very, very important, biologically important molecules. But they're heterocyclic amines. Pyrrole, pyridine. Pyridine is just has 1 nitrogen in the 6-membered ring, and it is a kind of a pungent, nasty organic solvent, and it's used pretty routinely in organic chemistry. Pyridine. But these are actually naturally occurring and essential rings. Okay. I'm going to be satisfied today if you just kind of get a little better idea of the naming of amines, and if we introduce amides. What is an amide? And name a couple amides. And then we can come back and look at reactions on Monday, in a week or so. So here is the amide functional group. You've got a nitrogen, so here's your kind of an amine kind of functionality, and you have a carbon-oxygen double bond. That nitrogen is bound to that carbon. So these things are right next to each other. A carbon-oxygen double bond with a nitrogen right next to it. This is an amide. To be distinguished from an amine. An amine is a nitrogen with three things bound to it, and one of them not being a carbon-oxygen double bond. This is in biological biochemistry circles, is referred to as a peptide bond, particularly when it's in a protein molecule. Proteins are called polypeptides, right? Polypeptides? Because the protein molecule has many of these amide bonds. That's what holds the protein together, is amide bonds. We'll see that in chapter 18. Chapter 18 in particular. Okay, so right up above here we've got a 2-carbon amide. All right, so what you do is the longest chain, 2 carbons, ethane, you drop the E and add amide to it, ethanamide. Okay, now this is a molecule that has that name, that's its IUPAC name, ethanamide. It has a common name. Think about what you think the common name might be. We've got 2 carbons. What have we been doing in common nomenclature when we have a molecule with 2 carbons? What's the prefix that has been coming up? Instead of eth, let me help you. I'm not going to tell you. That is ethanoic acid. right? That's its IUPAC name. What's its common name? Acetic. Acetic acid. Okay, let's keep going on here. Here is a 2-carbon molecule. What is that functional group? This is a little bit of a pop quiz. It won't be. It'll be an ungraded.
It's aldehyde.
It's an aldehyde. So what is the IUPAC name of that? 2 carbons. Ethanol. Now, you got it. You got it. You're there. Ethanol. Ethanol. And what's its common name? Here's a hint.
Wait, where's that?
Acid. No, it's acetaldehyde. 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 Okay. By the final exam, you will know all this. I assure you. All right? These are all things you should know for the final. All right? Actually, probably for the next test. All right? These pop up. These are the ones that I'm saying memorize that. It's got a very common name, acetaldehyde. You will read paper after paper that will talk about the effects of acetaldehyde on this, the effects of acetaldehyde reacting with that. Acetaldehyde. They'll almost never call it ethanol. Okay? So you won't know what they're talking about. You can't get in there with them because they're not using the IUPAC name. The common name is so common. We call that acetic acid. Vinegars, 5% acetic acid. It says it on the label. Doesn't say it's ethanoic acid. Doesn't say it in parentheses. Just ignores it. Okay? So here that ACET is corresponding to 2 carbons. Okay? Now let's get to where we are right now. Let's go to this molecule. Oh, yeah, we just named this one. We called it, here we are. We're right up here. There it is right there. Ethanamide. So what's the common name of ethanamide? It's 2 carbons. Acetamide.
Okay.
Acetamide. Or acetamide.
Doesn't sound right.
What did we do here? We said ethane, we dropped the E and added amide. We're going to take acet and add anamide. Acetamide. Or acetamide.
I'm confused as to where you're getting those from. Like, I get where you're getting the acet for the 2 carbons or whatever, but the whole, like, amide and all that.
Okay, I'm getting the amide because this right here, this is an amide. That's an amide functional group, just like an OH is an alcohol. Just like a carbon with an OH on it is an alcohol. That's the class of organic compounds it belongs to. The class of organic compounds this belongs to is the amides. These are all amides. Okay, since this was a pop quiz, here comes the challenging question. Everyone got those? Acetamide, acetamide, or ethanamide, acetamide, ethanoic acid, acetic acid, ethanol, acetaldehyde. All right, now, draw the structure of formamide. I'm not even being kind. Draw the structure from amide and then give me the IUPAC name of it. Form. What does FORM refer to? How many carbons? Why do you know that, Jesus? Okay. And what molecule did you come across that had FORM on it?
Oh, the first one?
Yeah.
I just remember it was one, told us form equals 1 carbon.
Yeah. So let's just go down here. You learned formic acid. You learned formaldehyde. And they were always 1 carbon. So formic acid is that 1 carbon. Formaldehyde is 1 carbon, but it's an aldehyde. And now I want you to draw formamide. Formamide. One carbon, and the amide, you got a nitrogen right next to it. And we've got one more hydrogen. It needs to be right there, right? Formamide. Okay, let's go around these 3 here and give the IUPAC name. These are common names. Formaldehyde is a common name of a compound, that compound. What is its IUPAC name? What's the prefix you use instead of form in IUPAC? For 1 carbon. Meth. Methanoic acid. Now this isn't methaldehyde, it's going to be methanal. We just use the AL ending. Methanal. And this is going to be methanamide. So all of these are 3x5 cards for you, but this is the new one, methanamide and formamide. Okay? This is a good little review. Now there's a slide coming, this slide right here. So you should know that, and you should know that. Common and IUPAC names, and that's about as far. I mean, if I gave you a simple amide like this, and said, oh, hey, what's the name of this molecule? And you would just give me the IUPAC name of it. If that's methanamide and that's propanamide, this is, oh, I gave it. Okay, if that's methanamide and that's ethanamide, this is propanamide. Okay, sometimes I give away the answer. That's why I don't give oral quizzes. I give the answers away. And we won't get much more complicated than that. I'm not going to give you this complicated molecule with methyls all over it and an amide on the end and say, name that. Could you do it? Yes, you could do it. But do be ready to do that with amines. But amides, I want you to basically be able to recognize an amide. We will talk a little bit about reactions and how do you make an amide and how do you use amides to make amines and things like that. So we'll talk a little bit more about amides, but I just want you to be familiar that you got this functionality right here. A nitrogen next to a carbonyl. Okay. And I think, yeah. I think that's before we